Hi everyone. In this video, we're going to discuss vectors. So what is a vector? So a scalar quantity is something that can be represented by a single number. So that is not a vector, that is known as a scalar. A vector, on the other hand, is something that has magnitude and direction, so it cannot be represented by a single number. Often a vector is going to be represented by a variable with an arrow over it and or in boldface, so depending on what you're looking. Now, when I write, and I fully expect you on your homework, whenever you write a vector, to write it with the arrow notation, because of course writing in boldface is difficult. But in a lot of physics textbooks, they'll use the boldface because they're typing and they can get away with that. But either notation is used pretty frequently. But again, in your homework, if you are writing a vector, you should always write an arrow over your vector to make sure it's clear that is what type of quantity it is. Because again, a vector is very different from a scalar, where a scalar is just a single number. So the magnitude or length of a vector is often represented by bars around the vector, like absolute value bars. And sometimes it's only represented by the variable alone. So if our vector was v here, then we could represent the length of the vector either with those absolute value bars or by just simply writing the letter v, and then that's telling you it's no longer a vector, it's just a scalar, and the magnitude of a vector is indeed just a scalar. The length is just a number, right? The length of something is just a number. And so we drop, sometimes people will just drop the arrow to tell you that it is simply the length representing that given vector. So some examples of vectors that we'll see in this class. So the displacement of an object tells you both how far the object has traveled and in which direction, right? So it's not just I went from home to the office, which I can't do these days, but it's not just that I went from home to my office, it's that, and that was 4 miles away, it's that I went south 4 miles to get to the office. So the displacement tells you both the total distance and the direction in which I moved. The velocity of an object is given by its speed, so right, like how many miles per hour I was driving, but also the direction of travel. So again, if I was going to my office to the south, then I would say that I traveled at a particular speed, 25 miles per hour traveling south, and that would give you the velocity. And really, it's only the velocity if you are sure to include that information about the direction as well as the speed itself. Acceleration, similarly, right? Acceleration tells you about whether you're speeding up or slowing down, or also actually it'll tell us whether we're turning. So if you're changing directions, that's going to be a form of acceleration. And of course, you can imagine if you're turning, right, there's some direction associated with that. If you're speeding up, then your acceleration is in the same direction as your velocity, whereas if you're slowing down, your acceleration is going to be anti-parallel to your velocity. Finally, in physics, we'll talk a lot about forces, right? Forces are pushes or pulls. If you apply a force to an object, you want to know which direction you're applying that force. Are you pushing on it or are you pulling on it? And so a force is also going to be represented by a vector quantity because you need to know how hard you push on something and in which direction you push. Okay, so I think that's all I'll talk about in this video. That's the basics of vectors. Again, a vector is a mathematical quantity that has both a magnitude or a length and also a direction. It's often going to be represented by a variable with an arrow over it or sometimes with a boldface. And throughout this entire class, we'll see tons of different examples of vectors. So these are going to be very, very important.